Everyone. So in this video we are going to discuss all about embeddings that we need to understand. I'm not talking about any technical discussions here right now. What I want to explain is actually what is the embeddings, how we are going to use it, why is it so important. And I tell you one thing that whatever has been done or whatever research has been done so far all over the industry in NLP, or I would say generative AI, or I would say LLM, all things are based on the embeddings. And here every time people have tried to improve the embedding so that they can actually improve their model. So we need to understand first that exactly what is this and why people are so much concerned about the embeddings. So before I go ahead, I would like to just mention a word because I'll come to that part again: encoding versus embedding. So this also I'll discuss today. But first, let me explain you what is exactly a embedding about. So have you ever wondered that how is it possible that a human brain is mimicked to some program, or I would say how exactly the AI works, right? So basically in general we say that in AI we always try to mimic the human brain, the way how our human brain works, and it is completely biological. So when I'm saying that I am implementing or I'm trying to achieve the similar task that a human can do, I am trying to basically copy its functionality somehow, so and give it to some system or some program, and then it can do anything, right? So when I'm saying that part, this is a brain actually. So when I'm saying that how does it work, I would say this can only be possible via maths. Somehow if I use maths as a language to tell my system or my program that it can do whatever my human brain is doing, it can perform any task. So when I talk about embeddings are generally used for the NLP task, natural language processing task, right? So when I have you ever wondered like how do I understand a language? Whenever I talk about something or I write something, a person can understand, read, or maybe like they can speak as well the language, right? And everyone says different language, and people understand differently also. So there are lots of things around it. But when I'm saying that I'm conveying something or I'm telling about something and you are able to understand, because somehow your mind is processing that information in different ways. So if I want to mimic that thing, or if I want to send it to the neural network, I have to basically convert that language into mathematical forms, right? So when I say mathematical form, it means whatever text I am giving it, I have to convert it into numbers. Maths is all about numbers, right? So suppose if I am saying she is studying, then I have to convert it into numbers. So generally when I say numbers, it means what we do, we actually represent it as a vector. You can say a vector, or right now to just understand it in the simplest term, you can say array, or I would say a box which has so many numbers around it. Now the question may come that why these so many numbers exactly? I'm still not able to get it actually what you are saying, what is embedding. So what I'm trying to say here is, somehow my goal is to run my program that somehow this text should be converted into number form. Okay, so when I'm trying to convert it into numbers, I can't directly assign this 1 2, or like I have assigned it 2 3 or 4, because she is studying has some meaning. But when I keep 2 3 4 as some number, then it does not make any sense. And if I can give them a one number, then also it does not make sense. So what is my goal? That convert it, it's not just convert it into number, it's like convert it into numbers, as well as it should have some meaning to it, or I would say pattern, or there is something through which I, whenever I convert again this number into language, I can actually understand what my user wants to say or program wants to say. Okay, so to do this I have to extract the meaning. So any method which helps me to convert the language into numbers, as well as it helps to extract any meaning or any pattern or any information, if it provides me about the sentence, then that transformation is called embeddings. Okay, so it's not just a numerical representation, I would say. Any numerical representation which has a significant meaning inside it, that is called embedding. So how it is different from the encoding, because in machine learning what we do, we generally have the categorical variable, and that categorical variable, like I would say high, medium, low. I suppose this is a value of a categorical variable, and I convert it into numbers like 2, 1 and 0, and also, sorry, 0, and also it has some meaning because 2 is the highest, 1 is the medium, and low is the 0. So there is an order around it, right? So how actually we like how this is called encoding. So how this encoding is different from the embedding. So to understand that part, you have to go little deeper. Actually, when I'm saying that you are extracting the meaning here, okay, from by converting it to numbers, then it is called embedding. You have to understand exactly how embeddings are being created. First of all, there are lots of types of embedding, so every embedding has a different way of creating. But in general, what actually, how it is, what does it represent, or how it has been created, I give you one simple example. Let's talk about a cake. I would say chocolate cake. And or let's not say chocolate cake, let's talk about the cake only, and I talk about the ice cream. Everyone knows what cake is and what ice cream is. But suppose there is a person who has never tried ice cream, or maybe never tried a cake. So in that case, if you want to explain, suppose I'm talking to my friend and he says that Arpita, I does not know sorry, I do not know that what is a cake about. So okay, so what I will do, I will try to explain that how does it taste, how does it look like, and what is it made of. So basically I can say is made of, okay, one thing. Or I can say yeah, I can talk about its taste, it what is made of, what is about taste, and also I can say how does it look like. Okay, so these are the three features through which I can explain that if it is made of, suppose I'm talking about the chocolate cake, it is made of chocolate, it can be of any flavor, okay, and how does chocolate taste look like, and I would say sweet for now, and I would say it's a generally okay, not just chocolate, it's, I would say, some flour also, okay, and apart from that, how does it look like, I would say maybe generally it's a round in shape, or maybe a little bit thick, something like this, and not too cold, I would say. Okay, so something like this I can explain. And if a person does not know what the ice cream is, again I can explain based on the similar pattern, that what is it made of. Then I would say, okay, if it's a chocolate ice cream, vanilla ice cream, okay, then, and apart from that, milk, okay, here it's considered as a chocolate, just an example I'm taking. And how does it, it is sweet, and it's too cold, and it can be of in the many forms, okay, how thick, how big, size, everything that matters, right? So basically what I want to tell is, if a person does not know how does a cake look like, how does ice cream look like, you will have another set of fixed words through which you can represent the cake is made of this. And by combining all these pieces together, a person can picturize a cake in their brain, and similarly they can picturize the ice cream in their brain, that okay, how does it look like. So basically that's the similar thing we do with the program, or we do with the neural networks through the embeddings. I would say neural networks because embeddings are generally used in the neural networks. So what I do to tell them exactly what the cake look like, I'll create a mathematical array, because obviously neural network understands this language only. So I would say, okay, let's talk here, I'm talking about the chocolate. Okay, here I'm talking about the chocolate, and here I'm talking about its taste, it's a sweet or not. Here I'm talking about shape maybe, or maybe like how long you can eat it or anything. Okay, similar feature, maybe 10 features I'm taking. Based on that I'm explaining. So I'm saying, okay, if it's a chocolate cake, or let's say I'm or adding an option vanilla. Okay, suppose it's a chocolate cake, I'm putting it 1. Okay, yes, it's a chocolate cake. It's a sweet, yes, it's a sweet. Then suppose if I'm saying round shape, okay, cake is round shape, I'm keeping it 1. Remaining maybe it's not valid here, so I'm keeping them 0. And similar vector I'll create for the ice cream. So when I'm saying, okay, suppose it's about cold, too cold. Okay, so it's not there, so I'm keeping it 0. But in case of ice cream, I'll evaluate the ice cream on the same feature set, and I'll say, yes, it's a chocolate. Okay, and it's a round shape, no. It's a sweet, yes. It's a vanilla ice cream, no. Okay, it's a cold, yes. And then I'm putting 0. Okay, so something like this I'll create. That's how actually these are being calculated. This combinedly actually it represents the cake, it represents the ice cream. And this you see, no, this array, this vector, this is called embeddings. Exactly, I am representing, and this pattern 1 1 1 0 0 0 0, this pattern has a meaning. Now how, if this is how embeddings are calculated, how other embeddings are different from each others. So it's just 1 and 0, 1 and 0. But maybe because when I'm talking about the cold, okay, and here I am saying, suppose, because cake is also sometimes cold, we keep it in the fridge only, right? So if I am keeping it 1 and here also I'm keeping it 1, then how will I create a difference? I need exactly that how cold it is, right? So maybe if I evaluate between 0 to 1, that how cold a chocolate cake is, maybe it's a 0.4, only 40% cold. And when I talk about ice cream, it's too cold, so I'll keep it 0.9. So basically I am changing these numbers, correct, according to exact meaning. So when I would say there are lots of embeddings, TF IDF is there, count vectorization is there, word to vec is there. Okay, word to vec is there, globe is there. So if you read about them, BERT is there. Every embedding has been improved somehow, how it is capturing the context behind it. Maybe it's adding some positions, maybe it's adding the nearby words, maybe the features. Right now I am considering only 10 features. Maybe if I consider more than 100 features, I can better represent that word, right? So that's how these are being different from each other. The better feature, more features, better embeddings, better representation of words, so it can extract a more accurate words here. So that's called embeddings. And when I talk about what is the difference between encoding and embedding, you can understand there is no context behind it. But now you might ask me that in the high low, the example that I had given, there is a little bit context around it, right? So I would say, because high I'm just giving at a number, okay, 1 2 0, something like this, but I am not correlating it with the other words, first of all. And also I am not creating, or I would say I am not extracting all the features which represents the high. So embedding is a kind of encoding, you can say. I would say more specific representation of each word. Here I don't care about much that exactly what it wants to say, high, medium, low. What I care about, it should be converted into numbers somehow, so that it can represent the different category, it can represent something. But if 2 is related to 1 and 2 is related to 4, I don't care about it at this stage. Yes, in the ordinal, or I would say where these values are actually related with each other, there can be some order in that case, but it's not necessary that it will always be so. And also one more thing, in the NLP we can't do the encoding, because a word can be converted into numbers. In the embedding, because we do embedding on the NLP task, and in the NLP the documents on the word that we take, sometimes it's a million. So basically, when we do encoding on some categorical variable, it has 2, 3, 5, 6, and maximum 50, 100 classes. That much only, that much value it have. But when I'm saying million words and I'm giving some token or some number to a word, then it can be a million words. So that does not make any sense. It's not necessary that one is connected to 1 million somehow. So that's how the difference is created between embedding and encoding. And this is a very generalized question that I ask in the interview, because you should have a knowledge about how different NLP and ML is. So it's a very important to know. So in the next videos, I would say I'll discuss these embeddings as well. But I hope this is clear, what is the embedding, how it is different, and how it is made up of. You can always remember the example of features, that if a person is blind and you want to tell the person that how a thing look like, you will tell about the features. And that's what same thing we do with the neural network. We tell them through the different features, and we take a set of features so that a word can, or a thing can be represented with that feature every time. So that's all for today. Thank you.